So the conditions, so the interpretations, you have to follow the sequence. First, adjusted R square must be between 0.60 to 0.95. If condition 1 is not met, you will stop there and you will not go to the next condition. You will only rebuild your model. If condition 1 is met, then you go to the second condition, the model p-value, which lies below the adjusted R square, must be less than 0.05. If this condition is also not met, you will stop there and go back and rework your model. The third condition is independent variables p-values must be also less than 0.05. The null hypothesis is independent variable is insignificant. That means it has no effect on dependent variable. Alternate hypothesis is independent variable is significant. So here we have an option. If any independent variable is found to be insignificant, we remove that variable and rebuild our model. So if you look at our summary reg, we have built this summary. Our adjusted R square, you can see here 0.5622, which is not in the range. So in the first condition only, our model has failed. So this particular model has failed in its first condition itself. And below itself, you can see the p-value. But the p-value is less than 0.05. And you can see the independent variables p-values. These are the independent variables p-values. See, most of the item types are non-significant. If it is significant, you can see the stars. If the variable is significant, you can see the stars. If there is a star next to the independent variable, that means it is significant. If there is a star, it is significant. If there is no star, it is not significant. It's a simple way of interpreting the output. So the interpretation of output in statistical software is different from Python. It is different from Python. In Python, we just get R square, we get the intercept and the coefficients. That's all. Right. Whereas in R or any statistical software, you will get R square. In fact, you will get multiple R square also. See, this is the R square. This is the actual R square which we get in Python, multiple R square. And you also get adjusted R square. Adjusted R square is adjusted to the variable significance, independent variable significance. If independent variables are found to be insignificant, the adjusted R square will be less than multiple R square. So this adjusted R square is what we have to look for when we are looking at statistical output. But when you are looking in Python, you will not get the statistical output. You will go with the simple R square, intercept coefficients, and RMS. Whereas in case of R, which being a statistical software, we must look at your adjusted R square first, then the model p-value, which is below adjusted R square. Then we should also look at the independent variables significance. The independent variables significance. Now we found out that all the item types and fat contents, they're all found to be not significant. So we can remove the variable item fat content, we can remove the variable item type, and we can rebuild our model. We can also remove item visibility. We can also remove item MRP. That is also not significant. Item MRP will be removed, item visibility will be removed, types will be removed, fat content will be removed, and we will rebuild a new modeler. Outlet size is also not significant. Rest of the variables are all not significant, item, location type, and all. So in this case, we have only two variables which are significant, which is the item MRP, outlet age, and outlet identifier. Only three variables are significant for regression. That means our final model will have only these three variables. If you are sticking to multiple linear regression, our final model will have only these three variables. But again, we need to use all other variables. The clients will insist, no, we have to build model with all other variables included. Then what option we have? We can't use multiple linear regression. We have to go to the next set of algorithms, which is tree-based models, decision tree. Then we will go and propose decision tree, which is a non-parametric algorithm, which does not have any assumptions. Multiple linear regression is a parametric algorithm. There are assumptions that have to be met before we conduct multiple linear regressions. Since we have outliers, that is one reason why the algorithm is failing. We have outliers, right, in our item outlet cells. That is, the positive skewness is there, because of which we are seeing what you call the model being failed. Basically, multiple linear regression has failed on this data. Multiple linear regression does not fit this data. We have to look for an alternative algorithm. Which algorithm? We go in a sequence. Decision tree we will try. We'll try random forest. We will see GBM. And then we will see neural network, whichever gives us the best R square, whichever gives us the lowest RMSE will be the best fit model. GBMs will perform well on this data, gradient boosting missions. Even if you do neural networks advanced with good fine tuning, hyperparameter tuning and all, it might give you good accuracy. But the data size is smaller for neural network. See, neural networks want large scale data. If they don't perform well on smaller data, because it's only 7,000 observations, 8,000 observations only, right? So it's a smaller data. Compared to industry data where we use 10 lakh rows, 15 lakh rows of data, this is a smaller data point, data size. And then we also have discussed the interpretation of the coefficients. This is again common interview question. What does coefficients mean in multiple linear regression? Coefficient will tell you how much the mean of the dependent variable will vary, keeping all other variables constant. What is the impact of that particular variable on the mean of the dependent variable is what your coefficient will tell you. If it is positive, it will have positive impact. If it is negative, it has a negative impact on the mean of the dependent variable. So the coefficient signifies how much the mean of the dependent variable changes given one unit change in the independent variable, keeping other variables constant. Keeping all other variables constant, if you change one unit of that independent variable, how much impact it has on the mean of the dependent variable. That is what your coefficients tell you. Okay, so the coefficients are also very critical in multiple linear regression. It's a very interesting, very important interview questions. What does coefficients signify? They signify the change in the mean of the dependent variable by one unit change in the independent variable, keeping all other variables constant. Okay, so this is what we discussed in the previous session, multiple linear regression. Now, we have our data, right? We have our data. What is the data here? BigMart train DF, right? I think BigMart train DF. See, the benchmark is, did I show this output in SAS? SAS is the benchmark statistical software. SAS is known to be the benchmark and the best statistical software. The only problem with SAS is it's very costly. Each license costs you 12 lakhs and you have to invest on servers and all those things. But this SAS on demand for academics is free of cost. It is given free of cost for training because of competition of R and Python. They were also forced to give this this version free of cost. So BigMart trained here. Okay. So same BigMart trained here. I have run the data. Let me see. Yeah, it's there. So in tasks, linear models, linear regression. Okay. Work dot import. So dependent variable is item outlet sales. Click OK. Classification variables. Classification variables means non-numeric variables. What are our non-numeric visible item fat content, outlet identifier, outlet size, outlet location type, outlet type, item code, right? Item type. And then continuous variables are your numeric variables. Item weight, visibility, MRP, and age. Okay, then we go to the model FX edit, select all, add to this model, click OK. Now it is all run in what you call click-based running. It is just clicking and running the model in. Now here you can see the R square, 0.5638. Right? Exactly what we got in our adjusted R square, 0.5623. This is actually the statistical output. SAS gives you the complete statistical output of the model. R gives you only the relevant statistical output which we need for decision making. R summarizes the output. Whereas linear regression has a lot of things. See here, AIC, AICC, SBC, then model p-value C. Even F value is 378.49. You will see the exact F statistic in R. 378.49. If you look at the F statistic, it will be same. See, F statistic is 354.1. And there is slight difference in F statistic. But you can see the same variables are significant, outlet age and all. See? The same output you will get. In fact, I think I have not given the plots. Actually, the reason why SAS was initially difficult was SAS involved a lot of coding. It is also coding based software. So if you look at the, now it is all click based. Now it is all automated and click based. But if you are looking at the code, this is the code. Earlier, some 5-6 years back, SAS means coding. We used to write this code. See, when I first interacted with SAS, so we have to use this code, proc gln select data is equal to work proc reg. So we used to write this code. Now it has become automated. We don't use coding anymore in SAS. It is all automated. It generates the code according to the variable selection we have done. But when I interacted with FA, we used to write a lot of codes. So this is one of the things which we used to know. SAS coding was required, and SAS Enterprise Minor, Enterprise Guide are also there. Even today, in Enterprise Minor and Enterprise Guide, you can do coding. Here also you can do code. You can write your own code. So based on that, you can do a lot of coding and all. So for large scale data and all, SAS is preferred because of its statistical accurateness. It is very, very accurate. It is compared. If you are comparing any statistical software, you have to compare it with SAS because it is the benchmark. So this is how the regression output will come in SAS. The only problem is we can't predict in this SAS thing and all, but basically SAS is the most advanced version, which is used in banking industry, pharmaceutical industry. It is widely used. Insurance, where you have regulatory compliance, there SAS is used. Pharmaceutical, clinical trials. For clinical trials, the only software is SAS. banking and insurance, if it is related to regulatory approvals, it is only SaaS. The problem is it's costly and it requires hardware investment also. You have to buy servers also. But now they are also offering cloud version. They tied up with AWS, GCP and all. They are offering cloud-based versions also, but still it is costly. Okay, so this is the regression, multiple linear regression, which we have studied in the last session. Any doubts? Okay. Now, the another data we were working is HR analytics, right? We were working on HR analytics data also. If you remember, we were working on HR analytics data where we have done the missing value imputations and all those things on our data. All of you can open the HR analytics file project. Okay, all of you open the HR analytics file. Okay, all of you open the file. Files. Now we have to split data back to train and test. We have to split the data back to train and test. All of you have this file, right? Right? HR train DF is equal to combined DF underscore imp square bracket 1 colon 54,808 comma. So we are selecting rows from 1 to 54,808. HR test DF is equal to combined DF underscore M square bracket 54,809 colon 78,298 comma. We are selecting the remaining rows as test data. Train data is 1 colon 54,808. Test data is 54,809 to 78,298. Row numbers. Comma after is row selection. Comma before is column selections. So we are, comma is very important here. Comma must be given after the row. So we have done the dummy encoding, we have done the missing value imputations, then we have separated the categorical data from numerical data, then we have combined them all into one single data frame, then we did the missing value imputations using mice algorithm. So mice is used to impute, we have imputed using the mice algorithm. Once the imputed data, we got the imputed data, we are splitting the imputed data into train and test. Hello? Yeah? Yes? इसके बारे में Okay. Now we will add dependent variable to train data. HR train df is equal to data dot frame HR train df comma is underscore promoted is equal to HR train dollar is underscore promoted. Rest of you guys got it, right? So here we have added the dependent variable back. Now, what is this? This is a supervised learning classification problem. This is a supervised learning classification problem. Why it is a classification problem? Because dependent variable y is non-numeric and binary. Non-numeric and binary, right? Because of the non-numeric variable is underscore promoted is our dependent variable, which is non-numeric binary. Yes or no? Whether the employee is recommended for promotion, yes. Employee is not recommended for promotion, no. Right? That is the thing. Now, when you have this, what is the algorithm? Binary logistic regression. Binary logistic regression explains the relationship, explains the linear relationship between a binary dependent variable denoted by y and multiple independent variables denoted by capital X. Binary logistic regression explains the linear relationship between a binary dependent variable y and multiple independent variables x. Right? And what is the equation? The equation is P is equal to exponential to the power of intercept plus b1 x1 plus b2 x2 plus b3 x3 b4 x4 till bn xn. And what is the denominator? Denominator is same, 1 plus. 1 plus, this is your denominator. This is the binary logistic regression equation. Binary logistic regression explains the linear relationship between a binary dependent variable and multiple independent variables. Now let us understand the equation. What is P here? Probability. P here is probability, and probability lies between 0 and 1. P is the probability which lies between 0 and 1. EXP, what is the EXP here? Exponential. What is the value of exponential? 2.718 something, right, to the power of EXP. Then B0 is what we call as intercept or constant. B1, B2, B3, B4 till Bn, we call them as coefficients. We call them as coefficients. X1, X2, X3, X4 till Xn, we call them as independent variables. We call them as independent variables. So in regression, we get a predicted value. In classification, we get predicted probability. The equations in classification algorithms will predict probability. The algorithms or equations in regression models will calculate predicted value. That is a big difference between regression and classification. And what is the classification rule? The classification rule is based on probability. Remember the classification rule? So what is the classification rule? Probability greater than equal to 0.50 will be classified as 1. Probability less than 0.50 will be classified as 0. And 1 is always yes, 0 is always no, until unless specified. Until unless it is specified, we assume 0 as no, 1 as yes, alphabetical order. Okay. Now the assumptions. All multiple linear regression assumptions or no. Y must be non-numeric and binary. X's can be both numeric and non-numeric categorical. Y must be non-numeric and binary. X's can be both numeric and non-numeric. There must be a logical linear relationship between Y and X's. There must be a logical linear relationship between Y and X's. No multicollinearity. No multicollinearity. And sample size must be 50 observations per variable. Sample size is larger here. In regression, sample size is minimum 20. Minimum 20 was the sample size in regression. In classification, minimum 50. You need to have a minimum of 50 observations or 50 rows per variable. These are the assumptions you need to understand when you are looking for binary or any classification model. See, sample size, these are the two basic requirements. There are formulas also available. But they are mostly academic formulas. So, population sample size, there are formulas like, number of variables and all, there are certain formulas but we don't use them in industry. We simply go with 20 observations and 50. Because anyway, it's a very large data in industry, right? In industry, we have to undersample. You can't build a model on 20 lakh rows, right? What you will do? You randomly select out of 20 lakh, 10%, 20,000 or 2 lakhs. You will take 2 lakh rows and then you build a model. Building a model on 20 lakh, 50 lakh rows will take a lot of time. And waste of time and waste of power. So what we will do is, we randomly undersample it to 2 lakh rows. Once we reduce the size, 2 lakh rows is okay. We can now 2 lakh rows is supported by both R and Python, very easy. Python goes up to 10 lakh rows. Python supports up to 10 lakh rows. So Python is now again, the next version, they are saying it will go up to more than 50 million rows. They are ready to go with more than 50 million rows also. So thereby, they are increasing the capability of processing. So you can directly connect the software to your database, directly import the data into your Python environment, and then you can run your algorithms. You can run your SQL queries also in Python. So now what is happening in industry is, we call it as streaming data. We pull the data directly into Python. Okay, then we will run SQL queries using MySQL or SQLite, or because all these are capable to run in Python. Then we will run the SQL queries. We will get the data to a proper structure. Once we have the data to a proper structure, we build the model. Once we build the model, we send it for deployment. So all these things, for you, there will be something called, when you're working in industry, you might not work on Jupyter Notebook or RStudio. You might be working on Google Data Studio. Google Data Studio integrates all. It will integrate the database. It will integrate the Jupyter Notebook into one single interface. In the Data Studio, you can write the query there. You can write the Python code. You can do everything in one single window. So that's how they are creating. Even Amazon, Azure, they have a common place where you can simultaneously run SQL queries. You can also run Python commands. You can also run R commands. So requirement for moving from one to another will not be there. So that is how you will work on data. And every company has its own interfaces. For SQL, there are a lot of interfaces available online also, right? You can change you can simply select MySQL, it will run as MySQL queries. You change it to Hive, it will run Hive queries. So there are all these interfaces are being created where you don't need to move from one interface to another, one single interface for all your things, so that you can focus on the algorithms. All these hardware related issues you can avoid, and you can focus purely on data analysis and algorithms. That is the biggest advantage. If you are more focusing on analysis and algorithms, you will generate a lot of value to your business. Client will not say, whatever you do, I want some business input. You tell me, what should I do with this data? And that should generate revenue. That should generate some sort of revenue, or it should reduce cost. Either increase revenue or decrease cost. These are the two things you can do. Once you show it to the customer client, you'll do. Sometimes nowadays we have a third option, reducing the computing time. Earlier, the query was taking 16 minutes to run. Now I have developed a query which runs in half of the time, 8 minutes. That is also a change. Because SQL sometimes runs, if you are trying to run an SQL on 10 million rows, it will take at least 10 minutes. Now MySQL has reduced the time to half. Latest version of MySQL. Same query, it will run in 5 minutes. PostgreSQL, 4 minutes. So that is how these SQL guys are competing. So larger the data, shorter the time. And the biggest advantage you will have is once you build a model, after that all you do is fine tuning only. Basic adjustments and all. Not that you will do models every day. Once you build a model, your job is to monitor the model and fine tune it. Whenever it just doesn't meet your requirements, you just alter the variables or just do some adjustments. That is how you will work upon. Okay, so any doubts in binary logistic regression till now? Now, the statistical interpretation of output. The statistical interpretation of output. Again, we get a very large output here, whereas in case of Python, what we were getting accuracy, and we were getting the intercept and the coefficients. And based on the accuracy, how is accuracy calculated? Based on confusion matrix. That is what we were getting in Python. But in R, we get a completely different output. The first thing is Akaikos information criterion. Akaikos information criterion, also called as AIC. AIC must be lower. There is no fixed range for AIC. Model that has lower AIC is the best fit. Best fit model. So the first parameter you need to look for when you are looking at the binary logistic regression output is AIC, also called as Akaikos information criterion. If you are looking at the formula is this: 2 log likelihood plus k n into parameters. K is equal to 2 for usual AIC, log n for BIC. So Akaikos information criterion is similar to R square. There is no fixed range. The lower the AIC, the better model. It's a comparative metric. It's a comparative metric. The second thing you need to understand is the null deviance and residual deviance. null deviance and residual deviance. Null deviance is deviance calculated with only intercept in the model and no independent variables. No independent variables. Null deviance, we call it as intercept only model. In null deviance, we have only the intercept. No independent variables will be added. Will be there. Residual deviance is the deviance calculated after adding independent variables one by one to the model. Residual deviance is the deviance calculated by addition of independent variables one by one to the model. So first we calculate null deviance, right, with intercept only. In the second iteration, intercept plus variable 1. There will be difference of deviance. Null minus that deviance, we get the residual deviance. Third iteration, intercept plus variable 1 plus variable 2. Again, we will get a deviance. You deduct it from residual deviance. You get the new residual deviance. Fourth iteration, variable 1, 2, 3, you get a deviance, residual deviance. That you deduct from residual deviance, you will get a new residual deviance. The final residual deviance we will get after addition of all the variables to the model. Null deviance must be greater than residual deviance. Null deviance must be greater than residual deviance, or let us say residual deviance must be lower than null deviance. Residual deviance must be lower than null deviance. That means variables are significant. If at all residual deviance is greater than null deviance, that means none of the variables are significant. So that is another thing you need to understand. Residual deviance must be lower to null deviance so that the variables are significant in impact. Three plus 9, 9. 9, 3, 3. Uttej is not there. Okay, so this is how null and residual deviances. I will show you the calculation procedure also, how it is done. The third is independent variables p-value must be less than 0.05. Independent variables p-value must be less than 0.05. This is the common between regression and multiple integration and binary logistic regression. If independent variables p-values are not less than 0.05, you remove that variable and rebuild the model. So this is the common. The other two are the different. And here accuracy must be calculated as it is not given automatically. In Python, we get the accuracy automatically. In Python, we get the accuracy automatically, right? Here we will not get it. We have to calculate it using the confusion matrix. Here we get AIC, null deviance. The interpretation is different in statistical software compared to a non-statistical software like Python. In Python, we just get the accuracy, the coefficients, everything is given. Here, we get AIC, deviances, and the independent variables p-values. We have to calculate the predicted probabilities then the predicted classes, then we have to do the confusion matrix. Once you have done the confusion matrix, we will calculate the accuracy. Okay. Now, let us build the model. Binary logistic regression. HR logit is equal to GLM, generalized linear modeling. GLM is the function, is underscore promoted tilde dot. Hey, we have any, do we have employee ID? No employee ID, right? Yeah, no employee ID. Is underscore promoted tilde dot. Tilde dot means include all other variables as independent variables. Data is equal to HR train DF, comma. The most important argument is family is equal to binomial. Family is equal to binomial. This you have to give, because family is equal to Gaussian. By default, family is equal to Gaussian. If you give family is equal to Gaussian, it will run multiple linear regression. It will give an error. It will say non-numeric data form. It will throw up an error. So HR logit is equal to GLM is underscore promoted tilde dot, comma, data is equal to HR trained here, family is equal to binomial. Summary, HR logit. Summary, HR logit. Now, what should we do first? You can see here. Yes. Akaika's information criterion. It is a comparative metric. We can't just go with it directly. We have to compare it with another model's AIC. So it's a comparative metric. Then you can see here the null deviance and the residual deviance. Immediately you can see the null deviance and residual deviance. Residual deviance is lower than null deviance, right? Residual deviance is 21,412. Null is 31,922. And what is the third one? Independent variables, p-values. Now you can see here, ratings. See, awards one is significant, KPIs met is significant, previous year rating is significant, education, region, department, length of service, age, number of trainings is significant. And you can see the p-values. See here, these are the p-values. P are greater than Z. Right? You can see the p-values. The p-values will tell you which variables are significant or not. Independent variables must be less than 0.05. So number of trainings is significant, age is significant, length of service is significant, average training score is significant, department is significant, region, I think not all, some of the regions are significant. Education, masters is significant. Previous year ratings except one, all are significant, and KPIs met and awards one is also significant. You can see the p-values, right? They are all less than 0.05. And these are the coefficients. We get the coefficients here also, right? So the first one, we call these are coefficients. The intercept is -30. You create the regression equation, right? So like how we created there, this is a different equation which we create using exponential. right? Exponential intercept minus 0.145 into training minus 0.02943 into age. Like that, we create a binary logistic equation. And using that equation, we will predict. Using that equation, we will predict. So we didn't get any accuracy till now, right? We have not got any accuracy till now. But the interpretation is slightly different here compared to the Python. Statistical interpretation is different. Okay. Now this residual deviance, ANOVA, HR logit, comma, test is equal to C capital CHIST. This will tell us the null and residual deviance calculation. Now you can see here. So you can see analysis of deviance table, binomial, link is logit, response is underscore promoted, terms added sequentially first to last. Terms means independent variables. Now the null model is here. Null deviance is 31,922. 31,922 is the null deviance. After addition of the first variable number of trainings, the deviance came down from to 37.2. So the new residual deviance is 31,885. After the addition of second variable, null plus number of trainings plus age, the deviance again reduced by 20.8. You can see the difference. Then length of service. Again, it has impacted the way thing. Length of reduce is 0 deviance. If it is 0 deviance, that means it is considered as insignificant variable. It is considered as insignificant variable. Average training score. See, 1,742, the deviance has reduced. And your reduced deviance came down to 30,117. So by addition of each variable, you can see in the end, the final deviance is 21,412. So this is how the null and residual deviance is calculated. Addition of variable at each iteration. Sequentially, first to last variables are added and the deviance is calculated. If the deviance is 0, it is insignificant variable. If the deviance has a value, it becomes a significant variable. The larger the deviance, the more the significance. The larger the deviance, the more the significance. If it is 0 deviance, it is straightforwardly considered as insignificant variable. Right? So this is how the null and residual deviance is calculated. The residual deviance must be lower than null deviance. Then we can say there are variables which are affecting the model. There are variables that are affecting the model. Right. Then we can say we have certain amount. See, it's all about how we build a model. Ultimately, we have to give certain variables to the client, and then he should be able to predict, and that prediction should be helping him to understand whether the right employees are being promoted or not. Based on the historical data, we are trying to assess whether the employees who are getting promoted have higher average training score, have met the KPIs, have won the awards. Are these variables significant in deciding the promotion? The model says they are. The model says, because that's what we want to promote, right? We want to promote the employee who met his KPIs, who has won the awards, whose average training score is higher, whose previous year rating is higher, whose age is also higher, who have attended number of trainings and learned new skills. So all these variables are found to be significant. That is how we have to tell the client, and then the client will also see that this model is right employees are being promoted. Even today, companies in India struggle because there is managerial bias, favoritism. That is the biggest problem in Indian IT companies. Even today, we have that problem. We might not have that problem in MNCs, but again, Indian MNCs work in India, same Indian managers will have the same problem. But the softwares which they implemented, like companies like IBM and all, Accenture, they have eliminated this bias. Managers cannot do anything. It's all about system feedback. You write your own KPIs, you give your own feedback, manager will write the feedback, the system will decide whether you will be promoted or not. Because it's all, if you go to Infosys TCS, it's all about favoritism. You have to butter the boss. Right? The more you butter, the more promotion you will get. Otherwise, no. Right or not? I'm not joking, right? Infosys, it's even the TCS, Infosys, Wipro, Tech Mahindra, it's all about butter. Butter, butter, butter. No work, only buttering. Creating confusion matrix. For creating confusion matrix, we need to do the prediction. HR logit predict is equal to predict HR logit, comma, type is equal to response. Type is equal to response. Table actual is equal to HR trained DF dollar is underscore promoted, comma, predicted is equal to HR logit predict greater than 0.50. You'll get a confusion matrix like this. Now, what is the accuracy? 49,811 plus 1266 divided by 49,811 plus 329 plus 3402 plus 1266. So we will get an accuracy of 93.1926. Accuracy of 0.931926. So the model is predicting with 93% accuracy. The model is predicting with 93% accuracy. Okay. Now, if you want complete the things, we have to install a package called Caret. C-A-R-E-T. Install this library called Caret. C-A-R-E-T. It's one of the important libraries of R. C-A-R-E-T, Caret. Oh, okay. Okay. So HR logic predict will give us probabilities. Once you have installed, please confirm, because HR logic predict is giving us probabilities. HR logic predict gives us probabilities. So we need to convert the probabilities to CARET. Did you install it? No. Click on install CARET. Check your internet connection, because this has to download from our server. Just check your internet connection. Otherwise, it will not download, because first time you are downloading, it will download from our server, cloud server. Next time onwards, you don't need to download. It will be there forever in your R Studio until you completely delete R and reinstall. Till that point, it will be there. Once you delete and reinstall R, you have to download all the packages again. So HR logit predict is equal to if else HR logit predict greater than equal to 0.50 comma 1 comma 0. So we are converting it into 1 and 0. So HR logic predict will give us the probability. What probability? Predicted probability. We get the predicted probability from the function predict. And then using the predicted probability and if else statement, if the predicted probability is greater than equal to 0.50, if the condition is true, 1, if the condition is false, 0. Same if statement. First is value if true, second is value if false, and a logical test. The logical test is greater than equal to 0.50. Now we can do the things. So in this caret package, we have a confusion matrix function. As dot factor HR train df dollar is promoted, comma, as dot factor HR logit predict. So we have to give the positive class also. Positive is equal to 1. So we get the same confusion matrix, you can see here. Then we get the accuracy 93.19. Then we can see the sensitivity, specificity, positive predicted value, negative predicted value, detection rate, balanced accuracy, positive class is equal to 1. Now, we also want that precision recall, right? You remember, we are more concerned about precision recall, F1 score and all. That also can be got. You can copy the command down, Control C, Control V, comma, mode is equal to correct underscore recall. This will give us the precision recall and F1 score. In Python, when we print the classification report, we get this precision recall and F1 score. So the precision is very low. F1 score is also very, very low because of the imbalanced data. We will work on imbalanced data later and understand how it impacts both in Python and R. For the AUC, they said they have added to confusion matrix, carrot package.
Just looking at a ROC curve starts to give us a good idea of how to evaluate whether or not our predictive model is any good.
I think carrot they have not added. They said they are going to add. They have not added. I think ROC curve is not there, so you have to depend on Python. I think we have to use the ROCR library. ROCR library is there. Let us see, we have that library. ROCR. Yeah, it is there. All capitals, ROCR. Library ROCR. That is equal to prediction HR logic predict, comma, HR trained here, dollar is underscore promoted. Is equal to performance, set, comma, this is dot. Okay, AUC, not ACC. Length of X and Y values do not match. Given correct only, why it says then as dot factor or logic predict as dot factor. Format of predictions is invalid. Zero and one only. Didn't make any. All right. We are not able to get the AOC curve. True positive rate and false positive rate. For doing the AOC curve, we need TPR and FPR. Okay, so we'll break for 15 minutes and then we'll come back. So you can predict. We have not predicted on test data, right? So in this thing, you can predict and submit into the competition site. So for predicting on test data, predict on test data, HR test predict is equal to predict HR logit, comma, HR test DF, comma, type is equal to response. So, so type is equal to response will actually for every predict function, for classification, what probability is predicted, right? So either it predicts the probability, type is equal to response means it will predict the probability. In some predict functions like decision tree and all, we get type is equal to class. Class means it will predict the direct 0 and 1. Here, logistic regression particularly predicts probability. So type is equal to response means it is predicting probability. It cannot predict the class. So we are converting the probability into class. So you have to go to help and you have to type predict.glm. So every what you call predict has its own thing. See here, it can be link, it can be response, it can be terms. Right. So link means what? Default is response. It will predict the response as the predicted probabilities. Okay. So similarly, if you are doing predict.rpart, you will get class prediction. So every predict function has its own type. So over a period of time, you will know for logistic regression, predict is equal to response is the default command. Now, HR test predict is equal to if else HR test predict greater than equal to 0.50, comma 1, comma 0. Now we will write it. Write.csv HR test predict, comma logistic.csv. It will write the CSV file. Now, once it writes the CSV file, you copy paste the predictions and submit, paste them into sample submission, and then submit it on the competition site. So a CSV file will be written. If you don't know where it is written, you can simply say get WD, it will give you the path. So for me, it is writing in this path, HR Analytics PGA 22, it is writing a CSV file. So get WT is to know the storage part. Write.csv is export CSV file folder. Then copy paste the predictions into sample submission file and upload. Once you do that, you will get the accuracy on the competition site. Got it, all of you? All right. Can we move forward? Done. Okay, can you proceed? So we'll go to the next model, or you want to practice on a data set? We'll go to the next model, decision tree, or we want to practice? Practice, okay. So file, new project, save the existing file, new directory, new project. We will work on what data? We worked on HR analytics, Big Mart sales, house prediction, right? Okay. Kaggle house prediction, we'll work on it. What data sets we worked on? Big Mart, HR analytics. One second. Let me see.